welcome to the second session under Unit 2, which is on alcohols and phenolic compounds. Now, at the end of the session, you should be able to use qualitative tests to identify alcohols or phenolic compounds. So, there are quite a number of qualitative tests you'll be looking at. The first one you can look at is the Lucas test, which is used to determine whether an alcohol is primary, secondary, or tertiary. Right. So, um, primary. So, primary alcohols do not react with the Lucas reagent, and the only time the reaction can proceed is when it is slightly heated in a water bath. Like, however, secondary alcohols will react slowly, not immediately. So between 3 to 5 minutes, and the tertiary alcohols react immediately when the Lucas reagent is added to it. So the negative test you've seen is this soluble, colorless liquid, while the positive test result is seen by the presence of the insoluble layer that is formed here. Right. So a positive test is noted by the presence of a water insoluble layer, the formation of the alkyl chloride. Right. Now tertiary alcohols react almost immediately to form a cloudy solution, which quickly separates into the two layers. Right. However, primary alcohols do not react unless they are allylic or benzylic. Right. So one typical drawback to this reaction or this test, which is the Lucas test, is the fact that um, alcohols that are insoluble in water will also be insoluble in the Lucas reagent, making it impossible to see that a new insoluble layer is formed. So there are some type of alcohols that are soluble in the Lucas reagent. So what happens is you end up with this result thinking that is a negative test. However, that will be possibly because the alcohol is soluble in the Lucas reagent. So please take note of that. Now, in the identification of an unknown, that's just as I mentioned, you know that the tertiary, the benzylic, the allylic alcohols will give an immediate cloudiness, right? Immediately you add the Lucas reagent, then the insoluble cloudy product is formed. However, for secondary alcohols, then the cloudiness takes between 2 to 5 minutes or 3 to 5 minutes. However, the primary alcohols may not react at all. You end up giving you the colorless or the clear solution. So this is basically a summary of everything on the Lucas test using the Lucas. Now the next thing we'll look at is the chromic acid test, right? Now primary and secondary alcohols can be oxidized by the chromic acid to aldehydes and ketones. So when you have the primary alcohol, secondary alcohols, they are oxidized by the chromic acid reagent to produce the aldehydes and ketones. So here we have our carboxylic acid being formed. And here we have our ketone being formed. So the tertiary alcohols do not react with the chromic acid reagent, right? Possibly because they do not have a replaceable hydrogen to the alcohol bearing carbon. So the compound is, so there's no reaction with the tertiary alcohols. Okay, so in your experiment to identify your unknown as being a secondary, a primary, or tertiary alcohol, then you add enough of your alcohol in 3 different beakers or test tubes, right? And then you add your chromic acid solution to it, and then you observe the color change, right? So a positive test should give you this blue-green color. Then, so the chromic acid reagent is kind of orange-like of the salt. So after adding this reagent to your substance or your unknown, the positive test result is this blue-green color. So which indicates that yes, your unknown is possibly a primary or a secondary alcohol. However, if nothing changes, then you can be sure that that unknown is a tertiary alcohol. So primary and secondary alcohols will be oxidized to carboxylic acid and ketones respectively. The tertiary alcohols do not react at all. So you have to take note of that. Now the biggest that have reactions take place may become opaque from the variety of precipitates, and the color can still be viewed from the inside. So observing the color change shouldn't be difficult for you. Now there's also the identification of phenols, right? And phenols are compounds with the general formula as the AROH. Right. So please take note of that. Now phenols are colorless unless some group capable of producing color is present. So without the chromophore, which might give a color to the phenol, phenols are basically colorless. Now they are acidic compounds, right? And however, except for the nitro substituted phenols, they are which are not acidic as carboxylic acid, and hence phenols are generally not soluble in the weakly basic sodium carbonate bicarbonate solution, but they dissolve in sodium hydroxide solution, which is more strongly basic. So their phenols are weak acids and do not react with weak bases except strong bases. Now, the presence of a phenol group can be identified using different chemical tests. However, there's also the solubility test that can also be used. So, um, the solubility test, phenols are soluble in dilute sodium hydroxide solutions, and water insoluble alcohols are not. So, this is probably the best method of differentiating between alcohols and phenols, right? So, water insoluble alcohols do not um, dissolve in dilute sodium hydroxide solution. However, phenols will dissolve in dilute sodium hydroxide solution. So it helps you to identify an OH group on an unknown compound as being a phenol OH group or an alcohol OH group, right? Now, in the identification of phenols, phenols react with ferric chloride to form green, blue, purple, or red complex ions, and the color determined by the structure of the phenol. So this color is as being blue, green, purple, or red. This complex ion that is formed here when a phenol reacts with ferric chloride is depends the color that is formed depends on the kind of substituent on the phenol that gives it its color, right? So that gives us the chance to identify an unknown compound as a phenol because alcohols do not react with ferric chloride, right? So this ferric chloride reaction test is for phenols and not alcohols. The color of the solution may be very faint. For this reason, it is good to run this test with a blank that contains the entire reagent except the phenol. So sometimes it's better to have your reagents in the same test tube as your unknown analyte so that you make references from that because sometimes the color change is very faint. Okay, so the bromine in water test can also be used to identify an unknown as being a phenol group, right? So we know that the phenol has the formula, phenols have the formula AROH. So the AR bearing the unsaturation can should give a positive test with the bromine in water as well as the OH group that leads to the substitution. So here the positive test is indicated by the precipitation of the substitution products at the same time that the bromine color of the reagent is being discharged. So we know that the presence of unsaturation will lead to the discharge of the bromine color, right? But here there's also the precipitation of the substitution product. So there's two things involved when we want to talk about the identification of phenols. So the discharge of the color due to the unsaturation, and then of course the precipitation of the substituted product, right? So that is the positive test result that indicates that this is this unknown is possibly a phenol. Okay, so still on the solubility test. Now, these aromatic compounds with ring activating substituents will give the positive test with the bromine in water, right? So we know of activating groups, right? The alkyl group is also an activating group. So the presence of this activating group will lead to the formation of the brominated product, and then these bromines go to the ortho and then the para position. So since in this typical reaction, the para group is occupied by an activating group, then the bromine will go to the ortho position, right? So the precipitate is the brominated phenol. So the precipitate receives the brominated phenol, whereas the color being discharged is also the presence of the bromine reacting with the double bond, right? Which is generally insoluble because of its large molecular weight. So the precipitate is formed and it's insoluble because the product has a large molecular weight, right? The substituted product that is uniform, that's the brominated phenol. Now, this is basically to guide you in writing your report. So you have to be able to outline the relevant solubility tests and chemical tests that are carried out to identify an unknown compound as an alcohol, being a primary, secondary, tertiary, or being a phenol, right? And then an unknown compound or phenol is when it's dissolved in water. What happens, and then you should be able to write chemical reaction for the reaction between your phenols and a ferric chloride.